Okay, next we want to explore a slightly different idea about inverses and what it means to have an inverse function. So if we look at the graph over here of f of x equals x squared, our parent mother function of a parabola, we can imagine what the inverse function might look like. Find an equation for the inverse function. Well, the inverse function would switch the x's and y's. And so if we had a point at 0, 0, the inverse would also have a point at 0, 0, 1, 1, stays 1, 1. The point at 2, 4 would become a point at 4, 2. The point at negative 1, 1 would be at 1, negative 1. And so you can kind of imagine that the inverse function would look like, that's very pretty, the parabola turned on its side. Well, that's a bit of an issue for us because that is no longer a function. If we go back to our definition of a function, what do we know a function is? Well, a function has to pass the vertical line test. And f of x here clearly passes the vertical line test, but its inverse here does not. So the inverse is not a function. And if we try to find the inverse function using the method that we learned above, apparently it's going to take me there. Using the method that we learned above, replace f of x with y equals x squared. Take this, we want to switch x and y. And then take the square root of both sides to isolate for y. We get the square root of x equals y. But technically, when we take the square root of both sides, we should include a plus or minus outcome. That could be y is the positive or negative square root of x. And if you remember our mother function for square root of x, square root of x is a function, but the square root of x is only the top half of this. It's only the top part of this. And this is I'm drawing kind of over it. And so it's not the entire inverse of the original f. And so f of x does not actually have an inverse function here. It has an inverse, but the inverse is not a function. And so we can't actually write it using this notation. Because remember, this notation is only for functions. This is function notation. And the inverse here is clearly not a function. And so what we have is a couple of new little definitions, and we'll use these in a second. And this says a function f has an inverse, that's a function, if f passes the horizontal line test. So what does that mean? We've learned about the vertical line test, but if we come to the original function f here, and we make a horizontal line, it does cross a horizontal line more than once. That means that its inverse is not a function. It does not have an inverse that is also a function. And what we call, if a function does pass the horizontal line test, then we call that function, it has a special name. It's called a one-to-one function. And a one-to-one function is a function that passes the horizontal line test. And if we're saying it's a function, then that automatically means that it also passes the vertical line test, because a function has to pass the vertical line test. And so if they have vertical line test, so if a function passes the vertical and a horizontal line test, then we say that's a one-to-one function. That means is each input has one output, but also each output has one input. So it works both ways. Where in the past, for a function, we just said each input has exactly one output. But now also it works the other way to be one-to-one.